Mic test 1, 2, 3. Okay, wonderful. Hello, everybody. So, welcome back to this YouTube channel. I know it's been a very, very long time. I'm not really expecting many people to come. This is really an impromptu video, really. And I thought I'd do it live because it's a bit of fun. A few of my friends have been waiting to see what I actually do on YouTube and stuff like that. So I thought I'd do it live. It's always fun. I've actually never done this before. It's my first time. And yeah, apologies for being absent for the past year. A lot has been going on in life. But we'll get more into that later. What I want to do today is really something for a friend of mine at work. It's his last week in the UK. He's personally worked on the Airbus A330 project, which is very, very cool. And I thought before he leaves, I'm going to make him a nice 3D printed Airbus A330. For people who are in on this stream, could someone please say something on the live chat, so just so I can make sure everything is going okay, and if you guys can hear me well as well. I'm just gonna write it down there as well. Cool. So I thought it'd be a nice, fun, interactive session if people join. And if not, that's completely fine as well. Really, this is more for myself and testing out if lives work. There have been a few of my subscribers who have been interested in this, so I thought, why not give it a shot? Cool. So as we said, I'm going to make this an Airbus A330. So this is very much based on the tutorials that I've put out a few years ago as well. They've gained up quite a lot of audience and very, very nice comments. So this is pretty much based on those tutorials. If that's something that you're looking for, please go ahead and watch those. This is more of a fun, interactive one. If you had any questions on what I'm doing, if you have any questions on anything that I'm doing right now, I do a few steps and okay, cool. Someone says everything is okay. Loki says everything is okay. Thank you so much to both of you for commenting. And let's get started. So the first thing I'm going to do is I'm just going to look up some reference pictures for the A330. It's always a good idea to have a look at what you're about to make in a little bit more detail. You never know, you'll find something that you didn't spot before. So what I'm going to do is I'm just going to bring this window to the screen where you can see it. And so we're seeing the A330. I'm just going to look at this one from the official Airbus. I'm just going to zoom in a little bit to have a closer look. So really, there's nothing too crazy about this aircraft, really. It's a beautiful aircraft, like all other Airbus aircraft as well. You've got your cylindrical sort of tube fuselage structure. You've got your beautiful wings. In this case, you've got 1, 2, 3, 4 flap track beams. Flap track beams are basically this thing 1, 2, 3, 4 on each of the wings. And these are basically what help the aircraft deploy flaps. So if you've ever flown in an aircraft, which I'm sure most of you have, and you're sitting on the window seat and you hear this sort of sound, that's basically the flaps coming down. And you can actually see when you're sitting on the window, the flaps coming down like this. It's a really beautiful sight. And the fun thing is the company that I work at now, we actually make these, which is very, 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 very cool. Right, so those are the flap track beams. We've got 4 of them here. We've got 2 engines, which is nice. We've got a very simple sort of wingtip design here. Nothing too crazy going on like the Dreamliner or the A350s. Or the 737 Maxes. This is pretty much just towards the end and then sort of goes up a little bit like that. From time to time, if you people are still watching, please keep saying everything is okay. If you find something interesting or if you find something that I've missed, inside the aircraft, please let me know as well. Thank you so much. Okay, then we've got your empennage, which is your two horizontal stabilizers. You've got one here and one here, and then you've got your vertical stabilizer as well. So really, a very, very typical aircraft. And when I make this aircraft in detail, it usually can take me between 4 to 5 to 6 to 7 hours, depending on the amount of detail someone has requested. So people, sometimes my subscribers do message me outside the YouTube channel when they select a particular model that they'd like, a particular scale they'd like to make, and I sort of make it for them. Now in this case, because I actually want to 3D print this, and the 3D printer that I'm going to use is not very detailed. It's decent enough, but you're not going to be able to notice massive amounts of detail. So I'm expecting to spend a couple of hours, but maybe not too crazy. I don't think I'm going to be spending 7 hours. In fact, I don't think I have time to spend 7 hours today on this. So the kinds of things that I'm going to be working on are the fuselage itself, obviously all the major components that I've already mentioned. I'm actually going to engrave the windows a little bit as well, so that when it gets 3D printed, you can actually see the sort of embossed look of the windows. Engraved look of the windows. I'm going to do the same thing for the doors, and hopefully we can also do the same thing for the cockpit. Okay, so that's your reference aircraft done. And I'm just going to keep this tab open just in case I want to have a look at something else. What I'm going to do now, I've already found a nice set of blueprints, which I'm going to open. And these blueprints I found off Google, nothing too fancy. So you've got your standard 3 views. Now the nice thing about this is it has just the right amount of detail that I would like to see when I'm modeling. So that includes your front view, your side view, and your top view. Again, very similar to what I've already explained in the tutorials. But you've got a few key dimensions. So you've got your middle section, so the fuselage width. You've got your length of the aircraft, so that's from the tip of the nose to the tip of the back side of the fuselage. You've got some wheel dimensions, you've got the overall aircraft height dimension, and again, you've got your length. So obviously, okay, so that's interesting. 60.3 for the length of the fuselage from the side, but 52.1 from the top. I'm assuming that's because there's something that I'm missing. I'm sure when we go into Photoshop, it will look a little better. Okay, we'll come down a bit more. And we've got the front view, and the front view, we've got the dimension for 10.7 meters, which is between the two wheels. Now, again, as I said, I want to 3D print this, so I'm not going to make this life size. What I might actually do is, let me think about this. So we've got 60.3. If we divide it by 10, that's going to be 6.3 meters. That's also too big. So if we do 0.6, let me just very quickly make sure my dimensions are okay. So ,60 centimeters. Now that could actually work, because 60 centimeters would mean yeah, 60 centimeters is basically like 2 ruler scales, and then we can scale them down a bit further if you want. Okay, wonderful. So I think what I'll do is, instead of 60.3, I will make it 0.603 and 0.169 and so on and so forth. Okay, so the first thing now we're going to do is we're going to go to Photoshop. And I'm just going to spend a few minutes cropping all of these. And then we're going to hop onto Fusion and make sure everything's okay. Lovely. I think I'm going to need the bigger screen for this bit, so bear with me for a minute. So even though you probably can't see what I'm doing, I am just cropping out the top view of the aircraft. Now again, because this is not going to be super detailed, I'm okay with missing a few accuracies here and there. As long as the model is still recognizable and the heart and the soul is still there, I'm okay with it. Okay, so we've got our top view. No, we haven't. I'm just trying to crop this. So what would be nice in this case is if I kept those lines that had the dimensions in them, and that way we can try and be a little bit more accurate. So I'm going to name this file the A330 top view, or actually to make it a bit more convenient, I'm going to say top underscore A330. My naming conventions switch so many times because when you program in different languages like Python or Java or React, you'll have different naming conventions. So depending on what language I'm using at the time, my naming convention for everything else I do in life also changes. It's really interesting. If you have related to this or I'm the only one going crazy here, do let me know in the chats. It'll be fun to see what you guys are up to. Okay, wonderful. So we've got our top view, which you can't see yet, but I'm just going to import it now. So import canvas, insert from computer. I'm going to go to desktop, A330, top A330, and I'm going to select the top view right there. I'm just going to scale it up so I can see it. And I'm going to turn it around 180 degrees, just so it's facing in the right direction. I'm going to press OK. And for now, this is good. What I'm going to do now is I'm going to go to the top view, make it a bit more comfortable. And from here, maybe I don't need to draw another line here. What I can do right away is I'm just going to right click and click on Calibrate. So I will follow, the thing is, you can follow any sort of scaling you want as long as you're consistent, in my opinion. Again, because I don't have to make this incredibly accurate, it's okay for me. So what I'm going to do is I'm going to follow wherever the arrow hits this line. So that point for me is right there. So I'm going to press that one. I'm going to roll back a bit and right there. There we go. So this dimension is meant to be 52.1 meters if I were making it to scale. And as we said, we don't want to do that. So what I'm going to do is I'm actually going to divide it. I'm going to do 0.5. Actually, hang on a second. I just want to make sure I'm in the right units. So it's millimeters right now, which is not good. I want to do it in meters. I'm going to press OK. And now I'm just going to try that again. So calibrate. Okay, so that's 0.16. We want it to be 52.1, but we want 0.521. So I'm going to do 0.521. There we go. So that's scaled it up quite a bit. Okay, what I'm going to do right away is I'm going to save this, right? I'm going to save this Airbus A330, and I'm going to call this Airbus A330. Wonderful. So we've got our top view sorted. What I want to do now is I want to import another view, and this time it can either be the side view or the front view. I actually like to do the side view along with the top view because you have at least the length of the fuselage in order, in scale. So I'm going to go back to Photoshop, and this is on another screen, so bear with me for a minute. One of the problems I face when dealing with blueprints, and maybe you've seen this before as well, you might get a picture that is a GIF or GIF or whatever you want to call it, and not a JPG. And most of the time it's fine, but sometimes you'll find that when you open it up in Photoshop, it won't be an RGB format. It'll be some index file, and you need to sort of convert it. I'm not a pro user of Photoshop, so I get confused sometimes, but it's pretty straightforward. You just need to convert the index into RGB, and you should be good. But sometimes it's too late to figure that out. So there are 6 people in the chat. Very, very kind of you to join me today. If you'd like to share your names and where you're from, what are you doing while watching this live stream? Are you studying? Are you building some Lego? Are you working, cleaning the house? Would love to know what you guys are doing while watching the stream. Okay, so the side is almost complete. There we go. Wonderful. I'm just going to import the canvas now. And this will be the side view. Okay, cool. So we've already done the top view, which means I'm going to select this right plane. I'm going to scale it up to something that's approximately the right size, just so we're in the same ballpark figure. Okay, I'm going to go to the right. And now, again, remember we scaled it, keeping our calibration points between where the arrow meets the line. Just to make sure everyone can still hear me. Wonderful. Okay, so side view, calibrate, and I'm just going to zoom as close as I want to, just to be as accurate as we can, being as comfortable as we can. Okay, wonderful. So this length is meant to be 60.3. So again, we can do 0.63. Nope, that's incorrect. It's 0.603. We could have made a mistake there, but that's all right. We spotted it early. So just to double check, 60.3, and of course we want to do 0.603. There we go. Now, at this point, what we're hoping is that we have somewhat of a good top view and side view matching. And we don't. Clearly, the side view is a lot bigger than the top view. And that's okay. We can still troubleshoot. We're still very early on in the process. And I think it's always a very good idea to do this as early as you can. You don't want to finish modeling your aircraft and realize you're doing the wrong dimensions. So what I'm going to do is we have a couple other dimensions we can work with. We've got your 16.9. You've also got your 25.4. And there's another dimension here, which is 6.7. So what I can do, I can actually double check if we calibrated this one right by checking the distance between this and this. So I'm going to choose that and choose that. And it's 0.147, which is clearly not correct when compared to the side view. And just to do another check, I'm going to measure this length and see. 0.23. So it seems like this one is close enough, but then that means that perhaps the top view isn't. So let's just do another calibration between the 5.6. So between this and this one, yeah, that's clearly significantly smaller than what we'd like it to be. We actually want this to be 0.56. So it's very possible that I calibrated this bit wrong, and that's completely okay. We're just gonna do it again till we get it right. So what's interesting to note here is that when we do the side view, we actually have it, from the top, when we do the length, it seems correct. But when we do the 5.6, it seems wrong. Okay, so how would we like to do this? We can, if things don't work out like this, you can choose to manually scale it up, but I don't want to do that just yet. What I'll do is I'll recalibrate. So it's 25.4 and 60.3. So this should be 0.254 and that should be 0.603. From here to here. So 0.254. So that actually scaled it up a bit. And 52.1. I worry that the blueprints are correct, but the dimensions might not be. Because why is this length, 52.1, the same as 60.3? So that's where my worry lies. 5.6, maybe we'll scale it up from here. So we'll do 0.056 in this case, because remember it's 5.6, not 50.6. So there we go, that became a bit bigger. Now we can try and have a look if it makes sense. Okay, so that's much closer to what we'd like it to be. Now, for the sake of time, ideally what I would have done is actually, you know what, let's actually do this. So I'm gonna go to a trusted source, hopefully, and I'm gonna actually check what the dimensions of the A330 are. And then that way we can be even more accurate. So A330, right, the 60.3 seems to be for the wingspan. So that's actually my mistake, because that 60.3 is not meant for this drawing. That 60.3 is meant for the front view, which we will import, and 60.3 is the wingspan. So that makes sense. This is good. This is good. This is live troubleshooting. In which case, it makes sense to not use the 60.3. It makes sense to use the 16.9, because that is actually part of the side view. So mistakes like this can often happen. And again, just a nice example to take it slow, make sure everything's okay, make sure all the dimensions are okay, because once you start modeling, that's all the fun bit, but you gotta sharpen your axe before you cut down the tree. All right? Hopefully you guys aren't actually cutting down trees, but that's a metaphor. Okay. So for here, I'll do 0.169. Oh, that actually made it a bit bigger, which is not good. Why has it made it a bit bigger? Okay, that's correct. Right, so we can do the 0.521. So this is going to become a little bit smaller, which is not great, because we do want that to be a bit bigger. All right, so what I'll do for now, I'll just scale up the Actually, we can do another thing. Because the wingspan is usually a very important piece of dimension, and Airbus says, or at least someone who online says, that the wingspan for the A330 200 is 60.3, and so does this blueprint. So if we can measure what this is, and I think I'll sort of settle for the wingspan. Calibrate. From there to there. There we go. So actually, it'd be nice if this was a bit bigger. So we can do 0.603. There we go. It's a bit bigger. And now that is starting to look much closer to where we started. Wonderful. I'm going to finish the sketch and I'm going to delete this because we don't need it. And I'm just going to close the origin and I'm going to start aligning these now. So the side view, edit canvas, I'm going to take the nose as the middle point here. You can choose whatever reference point you want, but I tend to either go for the wheels or the aircraft nose. So just something like that would be nice. Press OK. And now the top view, same thing there. So we're going to do edit canvas. Obviously, in the case of airliners and usually most aircraft, you'll find that it's symmetrical along this axis, which means ideally you want this to be centered as well. And you can see it's a little bit off axis, but that's okay. We can manually just move this. There we go. I'm going to press OK. And to make sure we're still okay, there we go. Look at that. That's beautiful. That is beautiful. So the noses meet, the wings meet perfectly, and the tip of the backside of the fuselage also meets really well. So this is great. Fantastic news. It always pays off, again, to spend a little more time making sure everything's okay in the beginning. Okay, our last and final view is the front view, which I will go and extract from the blueprints now. Okay, so I'm just going to import it now. Canvas, insert, front view, and there we go. So again, I'm just going to scale this to approximately what it's meant to be, and a little bit bigger. So we know that when we scale it, it's going to be snapping hopefully back to the red points there and there. So I'm going to create a sketch from the front. Again, you don't have to do this, but I like to do this just to maintain that it's a 180-degree line and there are no angles involved whatsoever. So there we go. This is, as we said, don't be deceived by that 19.4. That's for the blueprint that was above it, which was the side view. Remembering that the wingspan was here, 60.3. Okay, so what I'm going to do, I'm just going to finish the sketch, front, calibrate. I'm going to pick that point, and I'm going to pick that point, and I'm going to do 0.603. Now hopefully that will match pretty well with the rest of it. Let's have a look. Okay, wonderful. Now all we need to do is position it to its correct position. So front, edit, remembering that we want the nose to be centered to the origin. So something like that. Now let's have a look whether everything matches well or not. Okay, I think that looks pretty good. So all the noses match together at the same point. Let's do it from the front. Maybe we can have a look whether the wings match well or not. Okay, so they're pretty good as well. Sides looking good. Now we can also do this view to make sure. That looks pretty good as well. And finally, that view. So we can see that the height of the aircraft matches as well. So I think this is perfect. I'm going to go ahead and save this just so we don't lose anything. Now, what I'm about to do is an additional step. Again, you don't have to do this, but I like to do this because I feel like this view is really crowded. So remembering that in orthographic views, which is where we are right now, we're looking at it from an orthographic perspective. So it's not a perspective, it's an orthographic perspective, which means everything is 45 degrees and 90 degrees. So when I go to the right view, regardless of where the distance is, I'm always going to be looking planar to the side view. Same for the top view, same for the front view. But if I did perspective mode, you'd see that if I went further into it, the dimension sort of changes. You can see how the front view is moving respect to where my camera view is. So we don't want that to happen. We want this to be orthographic. Now, because this is orthographic, we have the benefit of sort of dispersing it in 3D space. So I'm going to go back in time and I'm going to construct some planes that we can offset from. So maybe we can do something like that and something like that and something like that. Again, guys, if you have any questions as to what I'm doing, if you're seeing this for the first time and you think it's cool, let me know. If you're finding it boring, let me know. Would love to really interact with you guys if possible. Okay, cool. So let's roll back in time now. Roll back to the present moment. Edit feature. So I want the down one to be down there. I want side view to be there. I want the front view to roll back in time. Wonderful. So now that we're all set up, I'm going to save this again. Now that we're all set up, we can actually start the fun bit, which is to actually model the aircraft. So we've already spent around half an hour making sure the blueprints are correct, they're correctly dimensioned, they're correctly positioned. Very, very important stuff. Okay, so similar to what I do in the YouTube tutorials, I'm going to create a new form and I'm going to go for cylinder. Again, because cylinder is the closest shape we can have for the fuselage of the A330. So I'm going to go cylinder. I'm going to choose the front face. And I'm just going to create an arbitrary length. Actually, no, we can actually go to the front view. Zoom in a bit, and you can see very, very closely this resembles a circle. So I'm going to do somewhat of an approximate size, so something like that. And symmetry line, we do have a symmetry line, so we want this to be mirrored. And we want it to be mirrored along this axis. So that would be not length, but width. You can see it's highlighted it in green. And that's very, very cool. So we're going to press OK. Great. Let's go back to the front view. Select all. I'm going to press M on my keyboard and I'm going to move this up. Again, you don't have to be incredibly precise, but I'm going to try. Now, again, because we said that we want to stay consistent with where our reference points are. So in this case, we can see that the blueprint obviously has a thickness. There's the above part and the lower part as well. What I'm going to try and do is stick to the above line. I usually take the center, but just to make it a bit easier in this case, I'm going to take the bottom line, which means I actually have to scale this up ever so slightly. But before I do that, I trust the side view way more than I trust the front view, because the front view can be deceiving. Sometimes you don't know. Um, front views can be illusioning if you don't know where the parts actually are. So what I mean by that is, if you didn't know that what an aircraft usually looks like, you would have no idea where the cockpit is from only this view. You'd have no idea where the wings or the empennage is only from this view. That's if you didn't know what an aircraft looked like. So sometimes it can be deceiving. So what I like to do is I like to start from the side view. So we positioned, because the calibration on the calibration positioning of the blueprints was pretty accurate, we can see now that the cylinder actually sits really perfectly. Even though we designed the cylinder from the front view, we can see that it matches really well from the side view. Okay, so just making sure everything is fine. Cool. So I'm going to press OK. And now what I'm going to do is I'm going to highlight everything, right click and press Edit Form. Now what this allows us to do is it allows us to manipulate every one of the vertices, every one of the edges, every one of the faces. Right now I just want to scale the whole thing up a little bit. So I'm just going to very uniformly scale this up ever so slightly. I'm going to drag it down. Now the benefit of dragging it in this view is that it doesn't matter how you move around from the side view, because your line of symmetry still remains intact from the front and the top view. Okay, so I'm happy with this. What I'm going to do is I'm going to go to the front view again, make sure everything's okay. So you can see it leaks a little bit down from this angle. And this could very possibly be due to the thicknesses of the lines on the blueprints. Because I chose to stick to the outer border instead of the inner border, it's possible that from time to time you'll see your lines leaking out a little bit. So for example, over here, ideally you'd like this to be flush with that one, but it's not. I'm actually okay with that for now. These kind of things won't be very visible when I 3D print it, so it's okay. But if I was making a model for someone, then obviously I'd be paying attention to these things as well. Okay, so over here we see as well, we can potentially increase the width of this a little bit. So I'm going to increase ever slightly there, and I'm going to press OK. Again, making sure everything looks intact still from all perspectives. They do. Again, except that little bit over there. Wonderful. Now, I'm going to start extruding this. So I'm going to double click, right click, edit form. Again, all of this is in the YouTube tutorials as well. Okay, press Alt on my keyboard and drag. Now, the lovely thing about the Airbus A330 is that it seems, at least from my first impressions, that the cross-section area across the span of the fuselage is pretty consistent. So I don't have to make a lot of adjustments while I'm extruding this. Okay, so I'm going to extrude it this much for now, and I'm going to check the top view, and it seems good as well. And I'm going to check the front view, and it seems good as well. Okay, so that's great. I'm going to now extrude a little bit more. And again, you can see it's relatively flat from the top and bottom. It's the same thickness throughout, which is actually making this modeling this makes it actually really easy compared to different other aircraft that I've worked on in the past. Now you can start to notice that it will start tapering. Maybe it bulges just a little bit over here, and then it sort of tapers off. So I'm going to continue extrusion, making sure that's fine still. It is. I think somewhere around here, I'm going to make the last extrusion, which I will not edit. So I think that looks good now. And now from this point onwards, we're going to start tapering it off very slightly. So first bit, I'm just going to extrude a little bit. Make sure it's fine from the top. Still is, good. Extrude a little bit more. And now clearly you can see that there's a gap between our cylinder and the blueprint itself. So now we've got to start tapering. I'm going to use this one, and there we go. Scale that in those 2 dimensions, and in this dimension as well, we can see there's a bit of a gap. So I'm going to now scale it very slightly, and I'm going to lift this up a bit so the top still remains relatively flat, whereas the bottom section has started to curve upwards and the top remains flat. Cool. Let's move on. So I'm going to repeat the process. Again, this is the point where you want to be a bit slow. You don't want to speed this one up because you want your curvatures to be as smooth as possible. You don't want them to look too funky. Okay, there we go. A little bit more. A little bit more. To try and keep, I think the general rule of thumb, if you've done calculus or you know what differentiation and integration looks like, the smaller your spaces are between 2 different points, the more accurate your curvature can be. So that's why in this case, I'm trying to keep them as consistent as possible. And then when there's a little bit more curvature, which we'll see with airfoil sections and we'll also see with the nose section, you want to add a bit more points there. Okay, so again, scale it down a little bit. A little bit more. There we go. Now we'll go for the top view and we'll scale it down again. Let me know how you guys are feeling. If what I'm doing is making sense, if it's entertaining, if you have any questions. I'm having a blast, which is nice. So over here, we can see that it's possible that from now, we're going to start benefiting from adding a little bit more cross sections. So somewhere like that, and a gradual taper, just a gradual taper. Cool, so I think that looks nice. There's a bit of a bulge here, which I'm noticing, but I'm gonna leave it for now. And if it looks weird a little later, because sometimes, I mean, I've done this so many times now that sometimes I feel like something's wrong when it's not. So I'm gonna leave it for now. And if I still feel like something's wrong, eventually I'll look into it again. Because my eyes are telling me that from here to here, it's actually going upwards, but I don't remember doing that. So it's not physically possible for it to do that. It's just my eyes are deceiving me. All right, such are the limitations of the human senses. Cool, so now that we're done with the back section, what I'm going to do is I'm going to leave it there, and then the rest of the section over here, I am going to loft it. So we've got quite a few cross sections over here, but I believe when we finish the form, they're going to disappear. So it's okay, I think we can leave them as it is. Now the front section is also an interesting one because usually the curvature from around this point starts to taper down, and then you've got this nose section, which can become tricky. And I believe a lot of my subscribers and people who have watched my videos have struggled with the nose section specifically. So let's see what happens in this case. Do the normal extrusion for now. And now from this point onwards, we're going to start tapering it up a bit. So okay, again, take your time. Making sure that every cross section is not rotated. It's a crucial key because a lot of comments I've also seen, they've sort of rotated the cross sections, and then when it got to the point of creating the nose section and this section had to be vertical, they couldn't do it because it was sort of inclined, which is not good. So you want to make sure that our cross sections are vertical as well. And again, at every step, making sure that it's okay from the top view as well as from the side view. Optionally, you can also check from the front view, but again, you won't have much perspective from the front view. Okay, maybe one last one till here. Cool, so I'm going to press OK. And what I'm going to do is I'm just going to double check. I'm just going to save this first. I'm going to double check everything looks okay from the side and from the top view as well. So I'm going to zoom in, and we've got the curvature here and here looking pretty smooth all the way throughout. And don't worry about this bit. This bit is actually the bit that connects the wings to the fuselage, which will come a bit later. Okay, and you can see this sort of tapers up very nicely. And I think my illusion bit is actually coming from the blueprint itself having a curvature, and I've not incorporated that curvature. I actually want to keep it simple because 3D printing, the way I'm going to 3D print this is not very complex. It's going to be very simple. I'm going to print this upright. So you want this actually to be as smooth as possible. Okay, so this looks good to me. I'm going to go ahead and press finish form. And you can see now you can't actually see any of the cross sections. Now, you may be looking at this and telling me, hey, you've spent about an hour reaching this point and it's underwhelming because it doesn't look like anything yet. I completely agree, but this is where patience is really important, because when we start adding detail, you'll start to see that what makes the Airbus A330 look like an Airbus A330, or what makes a Boeing 737 look like a Boeing 737, they're in they're in not so complex ways that they look different. Unless the whole body itself is very remarkably different, you won't be able to notice it. So this is actually a very nice classic fuselage design. So what I'm going to do now is, if I open the bodies, you can see that this icon currently, this is just a surface. We don't want this to be just a surface. We want this to be a solid body. So the first thing I'm going to do, I'm going to patch this. So I'm going to go to Surface, Patch, and there's an opening here. Remember, because we created a hollow cylinder and we sort of manipulated the cross sections of the hollow cylinder throughout. So it remains a hollow cylinder. So I'm just going to close this. And I'm going to close this. Now we've got 3 surfaces, and pretty simple. We're just going to stitch these together. So 1, 2, and 3. There we go. So we went from 3 surfaces to 1 solid. So if I click on this now, it is a single solid. Wonderful. I'm going to go ahead and save this. Okay, now comes to the tricky stuff. And this is usually where people have a not so good time. Creating the nose section. Now the nose section, I like to make using three sketches or three sections, I'd like to say, and they're sort of lofted together at 90 degrees to each other. I'm going to show you what that looks like now. Create sketch and at the nose section. And to have a very accurate split, what I'm going to do is I'm going to project what the front cross section of this aircraft looks like. So I'm going to choose these specified entities, and I'm going to click on this circle over here, which is actually the front of what we've created. I'm going to press OK. I'm going to press L on my keyboard, which is my line tool. I'm going to disable the 3D sketch, which you can't see because my face is covering it. So you can see the 3D sketch here is currently ticked on. I'm going to switch this off because we don't want to complicate things right now. So we're just going to do a very simple sketch. What this section, this icon or symbol here means is that it's the center. But just to be sure, I like to take the center from the origin. So I'm going to temporarily switch on the origin. And what's really interesting is that because the blueprints are aligned with the nose of the aircraft to the origin, and then when we created the cylinder, we took the center of the circle of the cylinder as the origin point as well. So now the origin point aligns with the nose of the aircraft. So therefore, even if I switch the origin off, it's actually exactly the same spot. So pre-planning things like this actually will make your life easier in the long term. So let's have a look what we can do now. So if I hover over this and I go up a bit, you'll see there's a dashed line, which means I'm directly vertically above it. So I'm just going to draw a line straight down, just so I can use this line to split that surface into two equal symmetrical parts. And I'm going to trim this and this. There we go. So if I press escape, you'll see that that sketch is now split into two different sections. Hey, Devon. Devon O'Neill. Thanks for joining us. Let us know where you're from. Okay, I'm going to go ahead and save this. I'm going to finish sketch because that's all we needed the sketch for, really, just to get that front section and have two symmetrical halves. Cool. Now, one other cool thing that why blueprints are really important. We're also going to create a section from the side view. And that side view is actually the same plane of symmetry for the entire aircraft. So I'm going to create a new sketch from the side. And what I'm going to do is I'm going to project now the whole body. So go ahead and press OK. There we go. And I'm going to use now the splines. So control point spline. Again, 3D sketch is off, which is good. And I'm going to just... So remember I said that when you have more curvature, the higher number of points you have, the more accurate it'll be. So you can see that as the curvature increases towards the tip of the nose, you want to actually add a little more points. So that's what I'm doing now. And then as we go along, you can sort of taper it off. Cool. Now, what's nice here is that this does not have to be tangential to that. So tangential would obviously mean this sort of line like this. Even this is one line and this is a circle. It's like this. It's tangential. We do not want this to be tangential because that's part of how the aircraft design is. And let's see what we can do from the bottom. Maybe perhaps the bottom can be tangential. Let's have a look. Sometimes it allows us, sometimes it doesn't. And I actually don't know why it does either. Okay, it allowed it in this case. You can see that that's the icon that's popped up, and that is your tangential stuff. Very cool. Devon O'Neill says, I'm currently in the US Air Force from Texas. Devon, thank you so much for joining. It means a lot. Are you a pilot? And how did you find this channel? And yeah, so someone else says, what is doing 3D sketch? So your username is a bit funny. If you could, funny as in it's, maybe I can't read it properly, but if you can let me know your name and I can address you in a slightly better way, if that's okay. 3D Sketch, you'll see when we create the wingtips. In the wingtips, we'll actually be using a 3D Sketch to sort of do this. Now, when you create a normal sketch is on a flat plane. So in the beginning in Fusion 360, when we have the origin, we have three different planes. We have your XY plane, YZ plane, and the XZ plane, or Z plane as you would call it. And because those are flat surfaces, you can create a 2D or two-dimensional sketch. But when you want to create 3D sketches, it doesn't matter what plane you're on. You're actually moving around in different dimensions. And it'll start to make a bit more sense. And you may ask the question, why would we want to use a 3D sketch? That's because when you're trying to do a sweep or a loft, then those rails or those guides become really, really useful. Devon says, I'm aerospace propulsion on F-16. My plan is to become a pilot. Devon, I wish you the best of luck. I think that's really incredible. F-16 Falcons, wow. The closest I've come to flying is Microsoft Flight Simulator and Ace Combat, where I do a lot of cool things. But yeah, that's incredible, and I wish you the best of luck. Cool, so now that we've got that, I'm going to finish this sketch as well. Devon, by the way, have you flown before? And while we wait for his answer, I'm going to go ahead and finish the nose section. So I'm going to create loft. And as I said, we are actually going to be looking at these three sections. So 1, 2, and 3. Okay, so let's see if this works. We've got 1, 2, 3. Okay, that's wonderful. And I think those people who are watching and have actually either watching now or watching in the future, if you've come across these loft issues where you'll say self-intersecting or Fusion cannot render the loft sections, just try to make the three profiles relatively close to each other and the proportions relatively close to each other. So you can see that this section here looks not exactly, but it's in the same sort of proportions as this one over here. And 1, 2, 3 here. Muhammad Ikram. Ikram, thank you so much for joining. Sending lots of love to your family. Ikram is a friend of mine from work. And he loves aircraft as well. Okay, I'm going to go ahead and press OK. And I'm going to switch the origin off as well. So Control S to save. And we can see here now that our nose is complete. Devon says, I actually watched your video to develop one of my first prototypes, so thank you. Devon, that's really, really nice to hear. If you have a few pictures you'd like to share, please shoot me an email. You can find my email on my website. Just contact me. I'd love to see what you're working on. And Devon, there's actually someone else from the US Air Force who I've been doing a project with for a past month and a half, or 2 months actually. I don't think I can share many details, but yeah, I've made a model, a very, very, very accurate model for him, and I really enjoyed doing that. So I'd love to see what you're working on as well. Okay, so the nose section here is, again, a surface, again, because we did a loft using the surface section. Because we want to turn this into a body again, I'm just going to patch up that surface. I'm going to hide the main fuselage, and if I see here, you can see this is a hollow surface. I'm going to patch this up. And now I'm going to stitch 1, 2, okay. There we go. So you've got your main fuselage here and the nose over here. Just making sure the battery on my phone is okay so I can make sure things are okay. Wonderful. Save. So that's one of the trickiest parts of the entire design done. Even though it may not look like that was the trickiest bit. Okay, let's go to the right section. And again, we want to do something similar here, very similar to what we did at the nose section. Now, it's very possible that for this back section, the loft may fail. And this is because you can see that this section here is going to be quite long, whereas the section over here is quite narrow. But let's give it a shot and see what happens. So similar to before, I'm just going to switch the canvas off because we're on the back side now. Create a sketch on this. I'm going to project just a specified entity. I'm going to press L, so I'm on the line. T, there we go, and there we go. Cool. Finish sketch for this one. Rotate. Create a new sketch on the side. And again, I'm going to project now the body instead of the specified entity. So I'm going to do that. Bring back the canvas. Create a nice spline. Again, the more curvature, the more points you'd like. So naturally, that's a nice thing to do there. That doesn't look very nice. So just to be as consistent as possible, I'm going to bring that up a bit. Now, we can see here that it'd be nice. Not a necessity, but it will be nice if these were tangential. So I'm going to try that out again. And usually at this point, Fusion can fail. So I'm going to save this before anything goes wrong. Tangent, this one to this one. See, it didn't allow it. And you can't see it because my face is in the way. But essentially it says, failed to solve. Please try revisiting dimensions or constraints. Okay, that also failed. No problem. It's fine. We're just going to go ahead and loft this for now and make sure that works because that is actually very, very important. Create a loft 1, 2. Ooh, it's looking good so far. And 3. Okay, so that worked. Again, my strategy, if that had not worked, was going to be to go back into my form and actually extend this bit a little bit more so that that section over here, from here to here, wouldn't be as long. But I don't need to do that. I think the proportions were, even though they were a bit out, it still worked, and that's all I'm happy about. So cancel, finish form, we're good. Okay, again, this is a surface, so I'm going to patch this up like I did with the rest of the bodies, and I'm going to stitch it up. So one there, finish. Now we have 3 bodies for the aircraft. Let me just check the chat. Devon again says, oh, very nice, you are a private pilot, and I'm willing to share that with you. Please do, Devon, I'll be waiting for your email, or shoot me up on Instagram if you like. Let me know what you have made. And if you guys are feeling inspired, you can join my Patreon. I've been planning to do these sort of Patreon sessions twice a month. So once in 2 weeks or once a month to start with, let's see, where we sort of come together and there's going to be an exclusive Patreon project where we come together and we work on a cool project together. If that's something that you might be interested in, go ahead and join my Patreon, and I look forward to having some fun with you all. I think it would be really, really cool to do that. One of my patrons who had been a patron of mine for about 1.5 years or 2, we used to jump on calls and we used to look at a design that he really wanted to do, and then we'd sort of try and build it up together. But for some specific reasons, he's had to cancel all his Patreon sponsors. So yeah, but we're still in touch. It's really nice. It's always such an honor to see how people have grown and how people have used your content to make some pretty cool stuff in life. So yeah, if any of you out here, the 9, 10, 11 of you here who are watching, if you've done some stuff with my tutorials, please do share. Honestly, it's such a nice feeling to see that. Okay, wonderful. So we've basically completed the very basic structure of the fuselage. I'm going to go ahead and press save. And again, just making sure that everything looks good from the side view. It does. From the top view, it does. And from the front view as well. It's always a bonus if you can hit the front view. Very nice. Cool. So the next section I usually like to work on is the wing section. Now, I don't know what the exact airfoil section is for the A330, but I'm more than happy to use an approximate section. Now, I'm going to go to Google and I'm going to look for a suitable airfoil section for this. Can't really find the exact one. Okay, so I found something, and that one belongs to the A320 and A340, but no. Okay, so in this case, what I have to do anyways during 3D printing is thicken up the airfoil, because from my experience, I've tried 2 and 3 times. And Ikram, if you are still on the chat, you know what I'm talking about. We 3D printed the aircraft, but the wing, the end of the wing, so the wingtip was too thin, and so it broke while we were trying to print it, which is not a nice feeling. So what I'll do is I'll actually make a relatively thick wing. And disclaimer, what I'm about to do is not recommended if you are actually building this for aerodynamic purposes and scaled model perspective, because in reality, your aircraft wing would actually have maybe 1, 2, 3 different airfoil sections at different spans of the wing. But what I'm going to do is I'm just going to literally come up with an airfoil and I'm going to sweep it up. Ikram is still here. He knows exactly what I'm talking about. Thick wing. Okay, let's do that. I'm going to zoom in, and what I'm about to do, there are multiple ways of coming up with the first airfoil section. But just to be a little bit more accurate, what I'll do is I'll start from the top view, and I know this might sound a bit strange, but I'm going to start from the top view, and I'm going to take the length of from here to here, and I'm not going to take care of this curve. I'm going to assume that the curve is not there. I'm just going to go straight in. This will just simplify things a little bit with respect to what I'm about to show you. I'm going to go to the point, line of symmetry, and go straight up. Wonderful. Now I'm going to press T on my keyboard. Bam, 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 bam. So what I've essentially done is I've approximated the length of the chord of the airfoil right here. Now, if people don't know what the chord is basically your sort of like your middle line of the airfoil section. Okay. So what I'll do now, I'm just going to finish the sketch, but I'm going to keep the sketch visible because I want to, when I create the new sketch, I want to project this specific line so I can know the exact dimension of the airfoil section. Side and side. And because we want our plane of symmetry to be the origin plane of symmetry as well, I'm just going to create a new sketch right away. Cool. And I'm going to press P on my keyboard, specified entity, and I'm going to project just that line that we just created and press OK. Now, even if I hide the sketch, we still have this sketch available to us. Okay, wonderful. I'm going to create a very random, and I do apologize for any people who've dedicated years on wing development and aerodynamicists, that I'm going to come up with a very random. Anyone watching from Airbus, I apologize. but we have to do this. This video is not sponsored by anyone, but if Airbus you are watching and you'd like to sponsor my videos, let's have a chat. Thank you. Okay, so specify first point. Let's go up a bit and let's throw in some points first. And instead of what I usually do in 3D models, I actually taper it off like this, but this is exactly where in 3D printing it goes wrong. You don't want a point to end like that, otherwise it struggles. So very cheekily, I will keep a bit of distance from here to here. Maybe make that a bit thick. And if it looks too strange, I may come back and change it. But for now, let's try and keep it like this. Mirror, mirror line. Okay. Cool. Finish sketch. And there we have it. That's our aerofoil section. Now, how do you actually sweep this into place? This is where you could potentially use a 3D sketch, but I tend not to because usually aircraft will have a steady dihedral angle. But if they have a more complex geometry, then you may choose to use a 3D sketch. I am going to construct a plane at angle using that as the chord line. So that is your chord line as I was talking about, sort of your middle section of the airfoil. Okay, now we can see that the plane that we're about to create currently is at 0 degrees to this. But you can see here that the wing is going to go up a little bit. Now in this case, if I had a bit more time, I would be using a 3D sketch to sort of carve out that section there. But we don't need to do that. For the simplicity's sake, I'm just going to lift this up by 5 degrees. I'm going to make the wing, and if it doesn't look good, we can roll back in time and change the angle of dihedral. So currently I'm just going to keep it to 5 degrees. Press OK. Okay, wonderful. Create a new sketch, and we're going to use the... Oh, Kushal's here. Hello, Kushal. Very nice to see you. Kushal is a very, very close friend of mine, and it means a lot that he's here. Cool. So as we said, we want to create the sketch on that plane that we just created, which is at an incline of 5 degrees. I'm going to project that line. Again, that's the same chord that we used in the previous to create the airfoil section. I'm going to press OK. There. Press L on my keyboard to draw the lines. And now I'm going to create the path and the guide rail for our airfoil section to follow and create the shape of the solid wing. So I'm going to use that reference point. Go from there to there. And you can see there's actually a little bit of curvature here around that section. But for simplicity's sake, I'm going to leave it as a straight line. Okay, there we go. And again, remember we said that we're not going to follow this path here. We're going to go straight. And we want this to be at the same level. Again, it doesn't have to be, but it's usually a better idea to do so. And there we go. That's our sweep path. I'm going to press Escape, Home, and you can see if I look from the front, the path is actually going to be at an incline, which is really, really nice. Okay, wonderful. Where is... Right, finish sketch. And now we're going to use this sweep. We're going to use this path as well as the airfoil section to create the solid. I'm going to press S on my keyboard before we make any new changes. I'm going to go to Solid, Create, Sweep, and our airfoil section is going to be this and this. So those are our base 2D profiles that we want to sort of extrude in a sweep. And I'm going to choose Path plus Guide Rail. I do not want to chain select, otherwise it gets a bit weird sometimes. I'm going to specifically select these two lines. So that's one. And the guide rail is going to be the other. There we go. Now it's showing red because by default, sorry, my screen's acting funny. Yeah, by default, it's showing red because it's coming from within the fuselage. So by default, if it detects that there's already a solid in the place where you want to sweep, it'll choose cut. We don't want it to cut, we want it to be a new body. And you can see there's a bit of a mismatch here. So instead of doing perpendicular to path, I'm going to do full extents. There we go. Wonderful. Let's have a look from the top view. That looks good. Let's get it from the side view. That clearly does not look good. You can see the wing, the entire wing is actually above. And this is because we were not careful with where we made that initial chord line. So this is a new lesson that I have learned. With this new method, we have to be careful where we made that initial sketch. So let's see if we can go back in time and edit that. Alternatively, we can just take this wing and move it down physically. But let's do it in a more systematic way. Just because if we wanted to create a change beforehand, we can do that. So I'm going to take that sketch. I'm going to edit sketch. And let's see if I can move this down a little bit. Okay, it's not letting me. And the reason is because this chord line is a projected line from the previous sketch. So if we don't change the previous sketch, it won't actually let me change this sketch. Make sense? So we're going to finish this sketch and we're going to go to sketch 7 where we made that chord line. And I'm going to edit this one. And of course it makes sense because we made this specific sketch, sketch 7, on the ground plane of the origin. So it literally chose that as a starting point for the wing. We don't want that. So I'm going to press M and I'm going to drag this down just a little bit because you can see that this line and this line will somewhere converge perhaps over here and then we'd incline it. So if I press OK now, I'm curious to see what would happen. I am expecting that the sketch 8 where our actual airfoil is made will also move down. And the inclined plane that we made would also move down, but it'd be on the same incline. Okay, ready? 3, 2, 1, go. There we go. How beautiful is that? So this is a really powerful technique of fusion where as long as you are referencing the right things from the elements before the timeline, and you change something in the past, everything will change systematically after that. I think it's very, very cool and very satisfying when that happens. Okay. Cool. There's a bit of a mismatch here. And of course, if we really wanted to, we could change this. But I'm going to leave this for now. And the reason is because when we make this sort of section over here, which somebody told me what it's called, but I keep forgetting. But I call it the wing to fuselage box, or some people call it the wing box, I believe. And it's a section that connects the wing to the fuselage. I'm going to leave the wing as it is for now. I'm going to save. We don't need the sketch anymore. And there we go. So now if I move around, this is now starting to come together. Wonderful. So the next thing I'm going to work on is the empennage section, which is the horizontal stabilizers. So this section here. Again, purely for simplicity's sake, I am going to make a symmetrical airfoil and a randomly generated one. So create new sketch. And we're going to be following a very, very similar technique to what we did for the wing. So actually, let me start from the top view again. So from this line to this line, and from this line to this line. Again, making sure that you've hovered over the origin at least once, so you have this reference line of symmetry. Pressing T on the keyboard. There we go. That's the line we need. Finish sketch. And now I'm going straight to the side view to create the empennage section. And what I can do is I can actually project this and this line, and I can just create a construction line straight up from it. So now at least we still have intact the chord line and where it's meant to be. Okay, wonderful. So create spline, control point spline. Gonna start there, make an arbitrary one. Again, just keeping it a little bit thicker than what we'd like it to be. 0 degrees. Remove that constraint so I can move this a bit back. And then I can create another spline from here to here. There we go. I know that looks a bit strange, but we have to keep it a bit thick for the 3D printer. This to this, press OK, and I think maybe that's too thick, so I'm going to bring it down a bit. Press finish sketch. Cool, so now sketch 11, we've got our two complete profiles there, so the top one and the bottom one. Construct plane at angle, that's there. And again, you can see this one also has a very slight dihedral. Maybe it's not as much as the main wing, but let's start with 5 again. And if 5 seems too much, again, we can just roll back in time and change the angle that we like. So 5. Sketch from there to there, go to the top view, project your chord line again. Remember, because chord line is the reference by which we're going to attach the path and the guide rail. So it's important that we get the exact coordinates. And from here, again, we can just create the snaps on. And that's there. And in this case, I don't think we can go all the way there. But again, for simplicity, we can leave it so that it goes till here. And because it's a symmetrical airfoil, we don't even need to do any complex lofting. We can just use the, what's it called? We can use the revolve tool around the chord line axis to actually create that curved section at the wingtip. But before we do that, let's sweep this. So let's sweep this to this. Path is this, guide rail is this. Again, simple, and we're going to create a new body. Press OK, done. So there we have it. Wonderful. It's 9:30. We've been here for 1.5 hours. Thank you all who have been sticking around. I'm probably going to be here for maybe another 30 minutes or an hour. But yeah, if you're watching this in the background while you're cleaning or you're studying or you're just spending some time here, thank you so much for staying. It motivates me as well to make more content like this for you guys. I've always had a lot of fun seeing people make stuff while I'm doing the dishes or just doing some simple cleaning at home. So I thought I'd make some stuff for you guys as well and see how the responses are. Okay, wonderful. So I'm gonna project now onto this, create another chord line at the end of the wingtip, finish sketch, and now all we really need to do is just revolve this one around this axis. And you'll see you'll actually get a very smooth section over here. New body, finish, there we go. Very, very simple. And actually I'm going to repeat the same process for the vertical section, which is the vertical stabilizer. So very, very simple, similar method. Go from line from here to here, and from here to here. Again, if we really wanted to, we could curve that up, but again, 3D printer and simplicity's sake, we're not going to do that. So let's create our reference airfoil over here. Again, because it's a line of symmetry, we don't have to worry too much about this dimension. It's already exactly where we need it to be. So finish, construct plane at angle, use that, 0 degrees, done. There's our new plane where we need to sketch our new airfoil. We need to project the previous section that we created, which is that bit there. And press OK. Again, I'm just going to create a very simple slightly thicker airfoil section again. So we'll mirror this. Mirror line is this. Press OK. Finish. Devon says you should play some lo-fi in the background. I completely agree. I personally don't know if YouTube allows that. I'm sure it does. I just don't know where to get the lo-fi that won't get any copyright strikes. Devon, if you have any suggestions, throw them at me, please. And for the next live, I'll make sure I come even more prepared. Okay, create, sweep these two sections. Path is here. Guide rail is here. New body. There we go. So this is really starting to come together. What seemed like an underwhelming start, because we spent half an hour to an hour basically just setting up the blueprints. But now it's starting to come together, which is nice. Okay, let's also make sure the tip of this is good. So I'm going to create a sketch at the top. And just the same technique, I'm just going to revolve this so that the end of the vertical section can be as smooth as possible as well. There we go. Very, very cool. No matter how many times I do this, it just gives me so much satisfaction seeing the aircraft come to this point. Very nice. Okay, I'm going to go ahead and save this, and I can hide any sketches we don't need. And at this point, we've got a couple of options. So we can either focus on the wingtip, the flap track beams, or the engine, or the windows in the cockpit. So for those 5, 6, 7 people who are still in the chat, you get to choose, if you like, which section to go for first. So the couple of options are your wingtip, flap track beam, engine, or the windows and cockpit. So somebody previously asked me, what's the use of the 3D sketch? So if you're still here, we can do the wingtips with the 3D sketches. Okay, no worries at all. I think I'll do the wingtips then. Now this is something we gotta think about. So you can see here that because of the inclined plane, our wing itself is also inclined. You can see the tip of the wing is not vertical, it's a bit slanted. So perhaps the first thing to do would be to cut it off flat. So I'm going to construct a new plane from the plane of symmetry and go all the way maybe till there, just so I can get a nice clean vertical cut. I'm going to use that as a reference line. Nope, not another one. Edit feature, go just slightly back. Devon says engine. I don't know, maybe there's a lag between the live and the receiving end, but yeah. Cool, so I'm just gonna split body, and I'm gonna split this wing using this newly constructed plane. And that little section there, we don't need it anymore, so I'm gonna right click and remove. And I'm gonna save that. Okay, we don't need that plane anymore, so I'm just gonna hide it. Now, one simple thing that we could do is we could create another chord line at the end of the wingtip, and then we could create an inclined plane where the winglet, that's what we call it, winglet, goes up. But I'm actually going to try and create a nice curved one, just because I think it looks a little nicer. So let's create a sketch on this. Project, okay, line from there to there, and finish sketch. And now, actually, within the same sketch, what I'm now going to do is I'm going to enable 3D sketch, and I'm going to start using fit point spline. So the 3D sketch won't work if you're actually in an orthogonal view, either on the front, side, or top. So I'm going to move a little bit, and now you can see if my snap is on, I can snap to that point in 3D space, which is very, very cool and very handy. So from the front, I know that perhaps it's going to go somewhere up until there. You can see the sketch is actually being drawn on this surface here, maybe up until there. And I'm just going to press OK because we want a single line, and then we'll move the tangents accordingly. Now we can see from the side, from the front view, this actually needs to go there. So I'm going to move this to the side, and currently it still only looks like a line, but don't worry, you're going to watch the magic. And now I'm going to move this a bit back, maybe till there. Cool. Now from this angle, I could keep it straight, but it would look slightly nicer if there was some tangency. Sorry, if there was a bit of a curvature. So I'm just going to bend this a little bit, just ever so slightly, just like that. So now it's going to do this sort of thing that the A350 does, where the A350s is even more beautiful. It's sort of, it's I don't know what they're called. Are they called sharklets, or? But it basically goes towards the back. I don't know how to describe it. It's just very beautiful. If you're keen, just search up A350 winglet. It's a beautiful carbon fiber design. Okay, and for the other section as well, I'm going to repeat the process. So that one also goes up until there somewhere. I'm going to just move that to somewhere there as well. And towards the back. And if we wanted to, we could leave this straight. There to there, there to there. This can go a little bit back if we want. And press OK. So the person who asked me 3D Sketch, if you're still here, this is the demonstration for it. And you're about to see something very cool, and I hope it really works. So finish sketch, create, sweep. 1 and 2. Path is this one. Guide rail is this one. And I'm going to press new body. And now it's created this really beautiful body. So if I go into the right view, you can see that it's actually curved ever so slightly backwards. Believe it or not, I've actually spent an entire hour in one of the models trying to make sure it looks as clean as possible. But for now, I think this will do. New body. There we go. So if we hide the canvases temporarily and we go into perspective mode, how beautiful does that already look? Very cool. Okay, so I'm going to save this. Now that that section is done, I think I can go ahead and work on the cockpit section. We're going to start making this aircraft look more and more like an A330 in a few minutes. So we'll switch the canvases back on, make sure we're on orthographic, and we're going to follow this here. Now before we do that, I'm just going to look at some more pictures of the A330 to make sure that we're hitting the right curvature in the lines. Now we could either go for the A330 classic cockpit design, which is what you can see here, or there's a slightly well, it's the same structural design, but there's a livery that has a bit of a sort of nice curvature just around it. Which, let me just bring this in here and maybe it'll be a bit more clearer. So here we can see, if I zoom in, you can see it's got this sort of black eyeliner, really, you could call it. And I just think it looks stunning. So we could do that, or we could keep the classic design, which if we zoom into this one, it's like this. So essentially they are, I think, at least structurally the same thing. It's just the livery has that little black stuff there. So regardless of what we make, this is the first thing we have to do anyway. So for the first one, which is the very side, we've got 1, 2, 3, 4, 5 edges. So really it's just a rectangle, and then you've got a sort of chamfer on it. And the second one is a little bit more complex. So you've got a vertical, and then it sort of curves upwards. Goes up, goes up, goes up, and like that. Okay, and then we've got your main where the pilot actually looks towards the front. So that'd be cool. Nice. Let's go to Fusion. And the first thing I'm going to make is this one. Now remember I said that I would follow the outer border of each of them. Unfortunately for the cockpit, we can't do that. Otherwise, it'll all look exactly the same. So what I'll do is, in this case, I'll follow the border inside. So let's do that. I'm going to create a sketch on the side. Devon says, so cool, man. Thank you very much, Devon. Line. I'm going to go perhaps from here. I need to actually switch off 3D Sketch, otherwise it's going to cause me some pain. Here to here here to here, here to here, here to here, here to here. I think in this line, I'll make it horizontal and move it a bit up so it stays consistent. There we go. And just a very slight radius, because if you know the story of the de Havilland comet, I believe it was, it had sharp windows, and what happens is the stress points on the corners of the windows, there's a lot of stress there, and it can start cracking, and your entire aircraft would implode or explode. So you never want to have sharp windows. So add a little bit of curvature just to keep everyone safe. Okay, cool. And we could perhaps, to make it a little bit cooler, although I don't think it would be reflected in the 3D printing. So I'm going to keep it like this. If you're doing this more from graphics perspective, what I would recommend is adding a bit of an offset. So if you use this tool, and if you add a bit of offset, what we can do is you can have the middle section black glass, and you'd have this section silver, and then you'd have your main aircraft livery. And you could really see the difference. Very small details, but these small details add so much value to the aircraft. Like, after these tutorials, anybody could or should be able to make the aircraft the way they want. But when it comes to these small details, it makes such a massive difference to anyone who's watching the process or who has the final product, really. So very cool. Unfortunately, the 3D printer cannot pick this up because it will be the same surface. So I'm not going to do this right now. I'm going to keep that as it is, unfortunately. And we're going to go ahead to the next one. So line, again, just reminding ourselves that bit goes a bit up. So I'm going to keep it at the same height. So we can do something like that, something like that, something like that, something like that, and something like that. Wonderful. 1, 2, 3, 4, 5. Just a little bit of curvature there. Cool. And the front bit we'll deal with from the front, because otherwise it gets quite distorted. So finish the sketch. And I don't want to really split the bodies in this case. I know in the previous tutorials I used to split the body. It's not necessary to do so. Even in the case of 3D printing, what I actually did last time was I just did a split face, and then I embossed the cockpit just a little bit inside. I think emboss is upwards, so I engraved the cockpit a little bit towards the inside. That's the word I was trying to use. Okay, so first things first, let's do a split face. So I want to split this face with this tool here. And I'm going to bring the sketch back because by default it goes away. Split face again, and I'm going to do this one. I'm going to temporarily hide the canvas and the sketch. And you can see it's got this interesting look now. And now if I go to the front, it also has an interesting look. Now it's very possible, before I switch the canvas on, that from the front view, this cockpit does not align. And hands up, I actually don't know what to do about that, but let's see how close it is. You know what, I'm a lucky guy today. That's actually not too bad. Usually I'll have the side eyes going, the side view of the cockpit going really far back. But I think in this case, because the A330's fuselage is relatively simple, it actually worked out pretty well here. Cool. And now I want to split the face from the front. So I'm going to create a sketch from the front. And let's have a look at some other reference images to have a closer look of where we can go with this. It really is just like a parallelogram. So let's try our best to try and keep that shape. So it goes a bit towards the side, a bit to the front, a bit more to the sides, like that. Okay, I'm just going to move that a bit. Again, remember to add your fillets, fillet, whatever you like to call it. And what we can actually do before we finish that sketch is edit, mirror, again, because we are doing this with respect to the line of symmetry, mirror line. Oh, where's the mirror line? Where's our origin? Origin is there. You can then use the origins line as the mirror line. And there we go, it's created it for us. Press OK, finish sketch, modify, split face, splitting tool. There we go. Oops, didn't like that for some reason. What's wrong? Compute failed. Okay, let's try it again. Okay, very, very interesting. So you can't see it because the error comes at the bottom right of the screen. My camera is there right now, but it doesn't want to split for some reason. No, it didn't like that either. So I'm just going to undo till before we got the mirror, because sometimes unintentionally, because we use the origin, it may have projected something that we didn't want to keep. So for now, we'll just modify and split face just with what we have already. And let's see if it's okay. Seems to be. Doesn't like that. Maybe there's something wrong at the back. So let's do that. Split face. And then we'll use this. I see. Okay. The problem we're experiencing here is that the front portion of the sketch is extending all the way back to the back section. And we can see here that the back section actually overlaps with the back of the fuselage that we made. So this body is a separate body to this one, and therefore it's like, I can't do it. So there are a couple of options we can do here, or a couple of options we have. We can actually try and combine these two. Let's just see what happens. Let's combine these two, and now they're one body. And now let's try this. Let's try to split the sketch again. But now we select both of them, and we do this. Okay, it didn't like that either. Okay, so now we'll just select one. See what happens. Didn't like that either. Okay. Any suggestions from anyone are welcome. I'm also going to try to not extend the splitting tool and see what happens. No. So what I'm going to have to do for now, again because of time, is I'm just going to move the sketch down. That's really all I need to do at this point. Just move the sketch down. Or we split it somewhere here. And the reason why that's an okay idea for this particular case is because I'm going to 3D print it. If a face is split, a 3D printer doesn't care. It's going to treat all the faces the same unless they're actually in a different width or height. So what I might actually do is I might, just for this section here, create a vertical line here, and I'm going to split face with this. Okay, and now really the guy at the back should not get bothered anymore because all I'm splitting is this guy. So that could be one way of going about doing it. So I'm just going to split the face from here to here, and now it should work. Oh, it still didn't work. Very interesting. It's above the nose, so it shouldn't actually matter. Okay, no worries. I think now the only thing we can do with the time we have available is I'm just going to move this down or make it shorter. Still didn't like it. If all else fails, there's this thing of have you tried switching it off and on again? So I've just deleted it, and now we're going to try again with a different sketch and see what happens. So let's come up with something a little bit more simpler and see if that works. If that works, then there's a problem. It's possible that the sketch we had created for the split was not good. I may be completely wrong, but it's always worth a shot to see what happens. There we go. So there were no complaints whatsoever with this normal rectangle. And you can see even at the back, it sort of doesn't care. So what we'll do is we'll just create a normal rectangle, and we're going to add some fillets to it. Okay, now let's see what happens. Now it doesn't like it. I'm not sure why. Really not sure why. 0.01 maybe. Pull this down. Still don't like it. So it's possible it's got something to do with the radius. So that's interesting. I'm not really sure what should be done here. For the sake of it, let's just keep it rectangular, but keep it a bit closer to the fit. And perhaps do something like that if it doesn't like radiuses. No, didn't like that either. What about this? Okay. I'm not exactly sure why that's happening, but let's keep it like this for now. And we'll come back to it a bit later if possible. So sketch, and for now we'll mirror this as well just to stay consistent. Origin, that line. Press OK, bring the sketch back. Split face, splitting tool. There we have it. This is starting to look like an old airliner, like where things used to look a lot sharper, and now all the aircraft look a lot sleeker and smoother. Cool. So what I actually wanted to do, and this is where the 3D printer can actually pick up stuff. If I click on these guys, and I do, let's say, a negative minus, can't do negative minus 1. What is 1 millimeter in meters? 1,000? So 0.00. Yep. So 1, 2, 3. There we go. That's exactly what I was looking for. So we've sort of engraved the main section. And what's happened here is very, very cool. Because now when we 3D print it, there's going to be a slight gap, and you can actually feel the cockpit, which I think is very cool. We'll give some radii to the inner bits, if we at least couldn't do it for the outer ones. Let's see what happens. 0.005, doesn't like it. 0.001, I think we can repeat the same for this one. Again, 0.001 would be nice. Cool, I'm gonna go ahead and save this. Now we are going to make the windows. So we've been here 2 hours, and anyone who's still watching, there are a few of you. Thank you for sticking around. If there's anything you'd like to say, any requests you have, any feedback, any thoughts, do let me know. Very, very much appreciate that. So I'm just spilling the fuselage face with this sketch. And what you can actually do in Fusion is you can take the feature. So in this case, the feature is a split. And you can actually create a pattern out of that feature, which I think is very, very cool. It's a rectangular pattern. And what we want to create a pattern of is the feature. And the feature I want to select is actually the split that we just created. The axis is this one. And let's count the number of windows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm actually going to do 17 here. And I'm not sure. There we go. So you can see it looks a bit funny now, but it will be okay once it actually performs it. You can see that there's the last window that actually needs to be there. So we just need to move it a little bit to the right. So 0.085 maybe. Okay, risky, but hey, look at that, beautiful. That was actually close to perfect. I think that's really cool. Nice. Okay, I'm gonna repeat now. I'm just gonna create another profile here. So if we go back to sketches, this one, I'm just gonna copy the sketch, and I can actually just use the same sketch really, because we're doing identical windows. So there we go. Cool, we're back to 5 people. Thank you all for being here. Finish sketch. Save. And now we're going to create a pattern for 1, 2, 3, 4, 5, 6, 7, 8. So first we need to split face. Devon, you're very kind. You say you are the master at work, man. Lol. I don't know if you know the hip hop artist Logic. He references young Sinatra. He references Frank Sinatra, where he says, "You are watching the master at work." And he uses his own hip hop name as Young Sinatra when he does his Young Sinatra albums. I think it's very cool. So it reminded me of that. Very kind of you, Devon. Thank you. Devon, you're asking which slicer do you use for 3D printing? Also, what 3D printer do you have? I personally don't have a 3D printer yet. There is a 3D printer at my workplace, which I use for different projects that we're working on at the moment. And my boss is very, very kind. He allows me to experiment and test the limits of the 3D printer. So I asked him if I could use the 3D printer to build a scale model. He said, yeah, of course, you're more than happy to. So the printer is a Creality Ender 5S. something along those lines. The material I use is PLA, and the slicer I use is actually Cura. So Cura has a inbuilt settings basically for the creality. So I basically just use that really. It's pretty straightforward. Let me know if you guys have any other questions. More than happy to answer them. Okay, again, we're gonna make a pattern of these features. So I'm gonna select this one. Axis is this one. And remember, there are 8 of them, I believe. 1, 2, 3, 4, 5, 6, 7, 8. 8. And we're just gonna drag these. Oh no. Actually, no. Let's see what happens. If you've spotted it, you see the amount of computations Fusion is doing right now. So it's very close to crashing. But let's test its limits. So 0.035 or 0.04. None of them will do 0.037. And let's see what happens. If I froze there for a bit, you know what just happened. It's computing a lot. Yeah, it didn't like that a lot actually. So I'm not sure why it didn't like that. Maybe because it's part of the same sketch and it doesn't like that. No, that shouldn't be the case. Features. Let's try it again, just to see where the problem is. It's 8 of them. And we want, let's just do 0.04 for now. And if that works out, then great. No, it doesn't like that. Fair enough, no problems at all. So for this one, all we have to do is we just have to create another sketch. But in order to do that, I'm going to copy this one, finish the sketch, create a new one, paste it here, drag it along a little bit. And you know, in this case, the spacing is 0.05, or we could do 0.055 or 53, 52, 51, 52. So 0.052. And if we can keep that number in mind, we can actually use the same number to do the spacing between all the other patterns as well. 0.052. Cool. Finish sketch, modify, split face. Splitting tool is this one. And in this case, we want 7, not 8. And remembering 0.0052, no, 0.052, but in the other direction. Okay, let's see what happens. Okay, it worked. Not very well, as you can see, because I got the number wrong. But maybe it is 0.052. Wait, how is that possible? So 1, 2, 3, 4, 5, 6, 7, but it didn't like the distance. Okay, let's split it in half, so that would be 26, and then let's see what happens. It's possible that it's taking a different sense of distance. Close. One more shot. So all we need to do is just drag this manually and we should be good to go. 0.032. Perfect. I apologize if I am lagging. And that's because there's a lot of computational spline cutting stuff happening here. Okay, there are two more of this that we need to do. We need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so bam. Devon says logic is dope, dude. I completely agree. He's the one of the first few artists that inspired me to start making music as well, which is on my other channel if anyone is interested. Okay, so we'll finish the sketch and we'll split the face. Should be pretty straightforward in this case. Save. And again, we'll copy the feature. We'll take the axes. In this case, there are 20. And we just got to drag. Maybe you can do 1, 0, 5. Yeah, okay, didn't like that. Let's try again. So, objects, axes. I'm still not entirely sure why it works sometimes and sometimes it doesn't work. So we just got to be patient. And try and figure it out. Okay, didn't like that. Maybe there's too many of them. Maybe we can do a batch of 5 at a time. Let's see how it would feel about that. Too many splines means too much computation, means it doesn't like it. So we want to do 1, 2, 3, 4, 5. So up until that one there. One, 2, 3, 4, 5. So 0.25 to 2 to 1 to 2. Okay, let's see if that works. Okay, doesn't like it, no problems at all. I think we're spending too much time trying to figure this out. What we'll do is I'll show you why I go through this headache in the first place. Because at the end of the day, you can do something like this. I think it'll be really interesting if it decides to fail while I'm live. So now I'm going to offset this exactly like I did for the cockpit section. So you're going to have somewhat of a, there we go. Beautiful. Two hours, 15 minutes in. Thank you everyone who's staying. I think we're expecting to spend a bit more. And Fusion has decided to crash. Gotta give it a couple. We don't need Photoshop anymore, so I'm just gonna close that up. Okay, there we go. So that's basically what I want to do. Now I can actually finish the rest of the windows and the doors at the end, so I don't bore you guys. But what we can do now is we can make the engines. So let's make the engines. But at least now you can see this is starting to look like an A330, doesn't it? Okay. So to make the engine, what I like to do is actually select to start by creating an offset plane relatively close to the center of where I would like the engine to be. And again, for simplicity's sake, I don't know why I keep saying simplicity's sake, but simplicity's sake, I'm going to keep the engine cylindrical. Okay, so there we go. I'm going to create a new sketch right here. And I'm going to, again, for simplicity's sake, make a sort of quarter section, and then I'm going to spin it around its own axis. Okay, so we can do something like this to this, and same axis, this to this, and then maybe we can just create a nice spline here. That itself actually does the trick. Now, if I were to revolve this section around its own axis, it's going to be a solid. We don't want it to be a solid. We actually want a little bit of, we want it to be like a hollow cylinder where the fan can come. Now, I don't know if the 3D printer will be able to take it, but we're going to try anyways. So I'm going to make this hollow. Now, the way I'm going to make this hollow is by using the offset. Maybe doing something like, okay, that looks good. And I'm going to modify, extend this sketch here and this sketch here, and I'm going to trim this and this. So now that's the section. Now, oh, that's not complete either actually. That's still going to be solid. There we go. Now it's going to be complete. Now if I revolve this around its own axis, it's going to create a hollow engine cylinder. Not mirror, sorry. Finish. Revolve. Use that as a cross section. The axis is this. And there we have it. So that is your now hollow cylinder. Okay. Again, if you make some, if you know why you're making the model, you can choose what kind of accuracies you want. You can choose what kind of compromises or simplicity sort of steps you want to take, and take them. Now, if you want to have a bit of fun and you want to make the aircraft as detailed as you want because you want to learn, I fully encourage that. Again, in this case, I want to 3D print this, and I know what the limitations are, so I'm going to leave it as simple as possible in this case. Cool, so I'm actually quite happy with that. The next thing I want to do is make the pylon. The pylon is what connects the engine to the wing section. So we can actually use the same plane, which is somewhere here, that we created the wing section on, the engine on. I'm gonna choose that plane, zoom in, and maybe hide the canvas. And what I want to do is I want to project this. No, I don't think we want to do that actually. What we want to do is that. That's what we want to project. Okay, and this is because we're looking to have the pylon sort of embedded into the wing, again for simplicity's sake. We don't actually need the airfoil itself. We just need the chord line. So I'm going to draw a line from there to there. And also maybe we can project the interesting. Do we need... Don't think we need that. So we can actually just take these two, and I'm gonna take the center lines and touch them there. We don't need that. We don't need that. We don't need that. We don't need that. All we need really is to a way to connect that line to that line, and perhaps we can make a simple sort of spline here. Again, if you really wanted to follow the exact path from the canvas, you should totally do that. I think it's really worth the effort. Cool. And what I can do now is either on that surface or on this surface, I can create a sketch, make a sort of airfoil profile, and sweep it. So we're basically just creating another wing, really, but it doesn't look like a wing, but it has the cross-section of one. So construct plane at angle at 90 degrees this time. Create a sketch, project the chord line, go back to the top. What happened? Did not. Projection link. That's the one we need. Spline, control point spline. Mirror line. Finish. Wonderful. So we're going to sweep now, and we'll sweep this section and this section. Path is this section. Guide rail is this section. So essentially the same principle we've applied from the wing and the horizontal stabilizer and the vertical stabilizer, and we're applying it all over again in this different section. So the really cool thing about 3D modeling, in my opinion, is once you understand the fundamental principles of how different shapes and the complexity of shapes is created, you can pretty much mix and match how you want to make stuff. There's not, similar to how we code and we program stuff in different languages, it's not so much about the language itself, it's more of the problem solving and how you know the languages, or how you can use your problem solving techniques and use the language as an advantage, as a tool to solve your problems. So there's not one single way of solving a problem, there's many. And in this case, it works for me, this is how I do it. By the way, if you do have any suggestions on how differently you do it, throw them in the comments. Love to hear it. Cool. So I'm gonna do no new body. It's okay. There we go. That was easy. Now, if you were building this for a remote control rather than just normal 3D printing, you'd actually be splitting these bodies as well. So you can see currently, if I look inside, that doesn't look very good. So what you can do is combine, but we can use the negative combine. So I'm going to combine. My target body is this. My tool body is this, and I want to cut. And I'm going to keep the tool as well because I want to keep the engine. Okay, Now what's going to happen, that body is now split up into this one and this one. So actually I can remove very safely this one. There we have it. Wonderful. I'm going to just save this. Cool. Now tell me that doesn't look like an A330. I think that's very, very cool. Okay, save. And now the next thing we can do is the flap track beams itself. Now, you could choose not to do it, but the reason why I actually want to do the flap track beam in this case is because our company makes some of these, and the project that my friend worked on was a flap track beam. So I want to actually make sure that we have that. Now, the interest of time, what I'm going to try and do is I already have some flap track beams made from my previous model, as well as the fan blades. I would like to make some new ones, but I think I'm not going to do that right now because it's going to be printed in quite a small scale. You won't be able to tell much. So I might pick, let's see if it works. If it doesn't, we can create some new stuff. We can go to the A320. And if we go to bodies and take the FTBs, there we go. So I can just, really, this is the cool thing about Fusion. You can just sort of drag along if you've made stuff from one to the other. So I'm going to copy this and I'm going to paste it in the document. It's not giving me the option to. No problem, there's another trick we can use. So if I create a component out of this, and then I copy the component, and I paste the component, it might let me. Let's have a look. Paste new. Okay, there we go, it's here. Where is it? But you see the size is incredibly huge, which is not good. So let's see if we can simplify this a bit. I'm just going to move this because that is meant to be half of the life size. I don't remember actually. So you can see how huge that is in comparison to the model we're making. So clearly this needs to be scaled down by quite a huge amount. So I'm going to just locate it approximately, and then I'm going to modify scale. And that's the entity we want to scale. Point doesn't matter yet. Let's just make it 10% for now and see what happens. Okay, it's much closer to what we want. Let's turn the canvas back on so we know approximately how big we want it. Okay, so let's scale it down a bit more. So modify, not shell, sorry, scale, entity, point doesn't matter. Let's make it half to start with. Okay, that's maybe a bit more. So let's make it 0.4. Now we need to go in small increments just to make sure we can keep track of where it is in 3D space and that it doesn't fly off anywhere. So once more, maybe we'll do 0.3. Maybe even 0.2. Okay, let's play with this. Let's play with this. So that's a little too big still, but we're getting very, very close to how we want it. Very, very close. Let's capture this position and let's see how it feels. Maybe we'll make it a little bit smaller. So we'll do 0.9, 0.8, 0.7. I think 8 was nice. There we go. I think I'm quite happy with that. Let's have a look and see if that fits our model or not. So we'll capture that position from the top. So from the top you can see it's leaking out a bit, which is not nice. We actually want this to be under the wing. That's okay, we can definitely do that. Still not. A little bit more. Slightly bit more. There we go. Cool, I think I'm very happy with that. So I don't need to spend half an hour making another flapjack beam. I'm just going to take this as it is and I'm going to duplicate these. So I'm going to take this out of the flapjack beam, so cut, and I'm going to paste it here. We don't need that component anymore, so we can remove it. I'm going to save this. And remember, if we looked at the canvases, there were 4 flapjack beams. So we've got 1, 2, 3, 4. So we're going to do that. And for simplicity's sake, I'm going to keep them exactly how they are. So I'm just going to copy paste 1, 2, 3, 4. So copy paste, move them across. Again, remembering the wing is at an incline, it's at a dihedral, so it's 5 degrees going up, which means if I take the flapjack beam from here to here, this one is going to be above the wing, as you can see. So actually we need to bring this down a little bit. So we'll bring it down a little bit. Okay, very close. There we have it. That looks good. We actually can move it back a little bit. That'd be nice. Move it down a little bit more. There we go. Perfect. Cool. Copy, paste. Third one. I think that's perfect. We'll copy paste this one again, and then over here. And bring down. Cool, let's switch off the canvas and see how this looks now. Nice. I'm happy with this, so I'm going to keep these flapjack beams as they are. Okay, I'm going to go ahead and save this. I'm going to cancel that, don't need that. Actually, there's one more thing I'd like to steal from this model I made, which is the conical sections. So if I make this as a component again, and then I copy from here, paste new. Okay, and again, this is going to be a huge fan. We need to bring it down significantly. So we're going to modify, scale, and I think it's safe to say even 0.1 is too big. But that's okay, let's at least put it into position to start with. The thing is, I could easily spend another hour making this fan when I don't need to. So scale as an entity 0.1. It's too small, maybe 0.15. That might actually be pretty good. Let's have a look. That's perfect, look at that. Wonderful. Cool, that looks really cool. Honestly, I sometimes forget I'm live. Thing is, with 3D modeling in CAD, it's very easy for me to go into a state of flow and completely forget um, that I'm in a certain place and I'm recording and I'm live. So that's nice. I actually feel quite comfortable. Um, glad to see a few of you guys are still here. If you're still enjoying it, please let me know. I think that's too big. That's quite big still. I'm going to scale this down a little bit more. Is this particular section I want to scale, not the... That might be a little nicer. So maybe even 0.8. No, 0.5 is fine. And then we can move it back a bit. Cool. Capture position. Right, what's left? I think the only thing that's left now is the belly, or the wing box, as some people call it. So let's work on that bit. Honestly, I still haven't found the most ideal way of making that section there. So what I do is I kind of I make a approximate loft between a section on the wing and a section at the plane of symmetry, and then I create some rails. And if it seems like it's sort of close, I'm happy with it. So construct, construct from there. So maybe somewhere there, and then I'm going to split the wing. Remove, there we go. Cool, and now if I create a sketch on the plane of symmetry again, and now this bit's tricky. As I said, I don't really have an ideal way, so I sort of just try till I get something that looks right. So I'm going to do that. So that's the wing section itself. No, we don't need that actually. We only need that bit there. Spline, control spline. So something along the lines of that. So you don't need to go all the way down there. You just did a bit above. Cool. Let's finish that, and you'll see what would happen if I just created a normal loft. Yeah, so that's prone to happening because it doesn't actually know how to sort of loft these two pieces together, because there are arbitrary number of points on the cross section I just created, an arbitrary number of points on the previous airfoil section. Now, if there was consistency, like let's say there were 100 points specifically on the airfoil section of the wing and another 100 points on the center section, it would try and harmonize them, but currently it's confused. So this is why I like to give it guide rails, and this is why, again, making the use of 3D sketches in this case is really, really nice. So I'm going to go ahead and edit the sketch. 3D sketch, and the first bits I'd like to match are between that section there and that section there. And currently I'm just sort of creating them as normal splines, but they will we will add curvature to them in a few minutes. The first thing is to sort of get the general, to just allow Fusion to identify where first it's supposed to match. So finish sketch, create a loft between this one and this one, and again it would intersect itself as it's saying. So we're going to guide it with some rails. One, oh that's interesting. Of course. This is one disadvantage of using control point spline. That it has control points and then the actual points themselves. So actually we don't want that, we want that. We don't want it to touch the control spline. We actually want it to touch the spline itself. So just trying to coincide that and that. Yep, okay, that worked. Hopefully, nope, that one's wrong as well. So we need to coincide that one to that one. Okay, that worked. And finally, that one's already okay. Now let's try and loft it again. So oh, what's happened here? Loft. It seems I broke one of the lines. So let's just undo till before we created the splines, and then we will redo them. No problem at all. So spline between somewhere there and somewhere there. Let's start with that and see how it feels. Sometimes when we do too much together, we can get confused ourselves and we can also confuse Fusion. So just taking it one step at a time. There we go. That's already looking a lot better than that sort of self-intersecting reverse Morbius strip. Cool. I'm just going to create a new body. Press OK. Don't worry, we're not actually keeping that, but that's a good first step. Let's create some more guide rails for it. So let's go from the back there to the back there. And now let's give it another rail, which is the one we just created. Step 2, there we go. That looks a lot better already. Now, if you wanted to add some more curvature, and I'll tell you where the curvature is really important, this section here. This section here. So let's edit the sketch again. From that point somewhere to that point somewhere. And now we need to add curvature definitely to these tools. So tangent handle. Now this is also risky because you're never actually sure how this would end up. But let's try that first. Rails. Ah, beautiful. I'm in luck today. Save. Let's bring that back. And I think that actually looks really cool. That looks very, very cool. If we wanted to add more, yeah, I think we definitely need to, because that doesn't look complete. So we're going to have to add another rail that sort of pops out a little bit and then goes into the fuselage. So let's have a look how we can do that. Or we could just use this one to do so. Perhaps. So if we used this one and created the tangent handle here, because you can see currently it's just sort of a straight 3D line going from one point to the other. But similar to what we did in the front section, we can actually create something like this. and see what happens. And you can see we're very close to having that beautiful curve somewhere there. So we can edit the line a bit more. Okay, let's have a look. Canvas off. That, I'm satisfied with that actually. That looks pretty good to me. I wonder if there is a way actually. Let's increase the, oh, I think that's messing it up too much. It's fine. I think we can stick with that. But you can see what we can, another idea I have is if we had some time. I'd take this and I'd extrude it a bit longer back, and that way this sort of spline that's coming in towards inside would blend really beautifully with the fuselage. But again, in the 3D printer, it wouldn't pick it up. So I'm actually fine with leaving it the way it is right now. There we go. Let's save that. Right, so that's actually pretty much complete, except adding libraries. And again, 3D printers won't be picking up libraries. But there is one thing that I will do after the video. That's going to add our company logos and stuff, which I don't want to do live. And I think that's pretty much it. I'm going to take one more shot at doing the windows in front of you guys. If it doesn't work, then I'm gonna have some dinner, because I came back straight from work and started doing this. So I'll probably have some dinner and then I'll continue. And then what I'll do is I'll post the finished pictures on the YouTube post as well as on my Instagram and Twitter, and you guys can have a look and how it turned out. But yeah, do seriously consider the Patreon sessions. I think we'll have a lot of fun if a few of us sort of got together, did some modeling to, once or twice a month. So just something to look forward to, and helping each other out with different techniques that we've learned in our own time and stuff like that would be really, really cool. Patreon link should be in the description. But yeah, let's try and continue the windows again. Okay, so we'll create a new sketch. And perhaps we can steal one of our previous sketches. There it is. Finish, modify, split face, splitting tool. There's this one. Create a rectangular pattern. So objects is this, axes is here, and we need, I don't remember how much it was. Was it 20? We're going to need 19 in this case. Come on, you got this. You can do it. You can do it, Fusion. You can do it. Hey, congratulations, you did it. I'm very proud of you. So instead of doing perhaps 0.10, which went a bit too far, we'll try 0.09, which is too little, so 0.095, which is too little as well, 0.097, no, 0.096, it was perfect, let's do it. Cool. And Fusion is crashing. All right, save before it crashes all over. Frozen. Save. Cool. And I think final set of windows we have here. So we'll create a new sketch. Oops. Switch off 3D sketch just in case. And that's why I generally don't know where the starting point of that window is, but we'll start from this side. Then we'll work our way back. So we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Maybe let's do 22. Let's see how it feels about that. Split face, splitting tool. Cool. So 22. Bit of I'm not sure how this is going to go, to be honest, but it's worth a shot. You know, let's try it out. 0.98, I think it was. Does that look about right? Let's have a look. I'm not sure if it's not responding or it's frozen or what's happening, but okay, didn't like that. Now what I've observed so far is that you do the first one and you try and do a pattern out of it. It doesn't work, but you do the second one and you do a pattern out of that, it works. So I don't know. Let's try. Let's try, shall we? Otherwise, you can spend a lot of time individually making the windows and individually splitting them, and that's no use. So we try our luck by doing it like this. Okay, split. Just got to give it some time because it's trying to compute 21 splines, but it's not only cutting it from one side, it's actually cutting it from two sides. So you got this, come on. Bless you. It did it. It did it. Nice. Now, if you go back to the other side, you'll notice that it's there as well, which is fantastic. So I'm just going to save this, and I'm very happy that it worked. And I think there's two more things I'd like to do. One is I'd like to engrave these windows, and then I'd make the doors, and then we can call it a day. Sounds like a deal. So 1, 2, 3, 4, 5, 6. No. What's going on? Ah, I see. Forgot about that. 001 is what we need. There we go. That's better. And we can continue. I think I clicked something wrong by mistake and it's struggling, so we'll just do it in different steps now. 9 o'clock. We've been here 3 hours. 3 hours, guys. Thank you for sticking by. I hope wherever you are in the world, you are well nourished and hydrated. It is the summertime. And that you guys are feeling okay in whatever you're doing, wherever you are. Again, because it's computing splines, it's taking some time. I think we can delete some of the things we don't need. It's not responding now, which is not a good sign, but let's keep it going. Stay patient. Okay, so it's possible that we might have to restart Fusion. crashed. So let's restart Fusion. No problem. Okay, we're back. Yeah, so this is where we sort of left off. I think instead of engraving the windows, what I'll do is I'll just make a final sort of the doors, and then we'll mirror, and then we'll have a look at what the final thing looks like. I think it'll be very, very exciting to see. So if you want to wait around for a couple more minutes, I think the end is going to be absolutely worth it. So we'll reduce the size. Finish sketch, modify, split face, splitting tool. There we go. And I think I'd like to keep that sketch. To another one here. I think there's no use doing a pattern in this one because the doors are not evenly spaced, so it's fine. And I think we can also make use of the one there and one more. Okay. Split face. Two more to go. Split. Wonderful. All right, there we have it. Cool. So now, ideally, what I would have done is actually engrave the stuff. Let's actually give it a very quick shot if we can. Because there's only 4 of these. Just in case beforehand. Oops. Okay, let's try that again. So 1, 2, 3, and 4. And now we'll do minus 0.001 because that is a millimeter. We'll press OK. Yeah, it is being buggy. So I think finally what I'll do instead of Thank you for this live. I've understood all in English, even is not my native language. Now I have to leave because it's already night in Russia. So bye. It was nice to spend time. Very kind of you. Thank you so much for tuning along, for really staying for the whole thing. I think that was really kind of you. I think I'm lagging, so I'll stop speaking. Yeah, okay. We're gonna stop doing this engraving stuff because it's. I think Fusion by itself is buggy, but because I'm also screen sharing at the same time and it's streaming, it's really struggling today. So I apologize for that. Okay. Won't be surprised if Fusion crashes again. Apologies. Okay, at this point it's probably better to restart. Five, four, three, two, one. Okay, so if I'm audible now, I just wanted to say thank you so much to the person who just left. I don't know who they are, but they spent the entirety of 3 hours with me here, which is very kind of them. Hope you enjoyed it. And literally, I'm just about to do one final thing, and then we're going to call it a day. My eyes hurt. I need to take my contact lenses off and wear my glasses and have some food, which I'm looking forward to. So we'll take away the construction, and yeah, pretty much that's it. So take the canvas off. I'm going to create a mirror, and we're going to mirror the, we don't need to mirror the fuselage really, but we can mirror the, nope, not that either. I think if I do this, it might be better. Not the faces, the bodies. And mirror plane is this, and we're just going to new body for now, and perspective. There we go. Look at that. That is a beautiful, beautiful Airbus A330. I'm very, very happy with how this came about, and honestly, it looks pretty, very, very nice to me. And just for presentation purposes, I guess what we can do is add a bit more appearance to it. So I usually, for these kind of aircraft, I usually just go for a nice white base. So I'm gonna, for now, select all of them, white. And because this was a different component, the engines have stayed black. What we can now do is, just for the surfaces, a 3D printer is not going to pick this up, but just for my own satisfaction and because you guys are here as well, I'm going to install a heavy glass color. And you can also do this for the windows, but the windows have been giving us some trouble today, so I'm going to sort of do that towards the end. But yeah, that's pretty much it, guys. Thank you so, so much for being here with me. I could easily spend 2-3 more hours fine-tuning some of the stuff I've done here. That is actually how much it takes me to make a nice model. But even with all the simplifications we've made and all the complexities that we have removed, still, it looks really, really good. and I'm very happy with how this turned out. Let me know what you guys think. If you guys would like to see more live stuff, please let me know. I mean, look at this. This file structure is also a mess. Nothing is named correctly. But yeah, that's the limitation of time at the moment. I'm going to clean this up a bit after. But if you guys would like to see some more live stuff, let me know. Let me know what it is that you'd like to see. I'd be very, very keen on doing more of these at least once in a while. I think it's quite fun having you guys here, me just having some fun, answering any questions you have, so on and so forth. I do intend on finishing the car model series as well, so watch out for that. And yeah, if the Patreon Fusion series is something that you might be considering, the link should be in the description. You can join my Patreon, and once or twice a month we'll meet up on Zoom and we'll do some cool stuff together. All right, guys, thank you so much. Have a great day wherever you are. Devon, thanks for tuning in. Ikram, thanks for tuning in. Kushal, thanks for tuning in. And all the other people who have been watching and whose names I don't know or are not visible, thank you so much. Take care. Goodbye.